This video will give you a brief introduction to the ANOVA assumptions. There are three primary ANOVA assumptions, and all of them are in relation to error, where error is determined by comparing the expected value to the observed value. And error then is determined by how far is your observed from what is expected. So all three of these primary assumptions for ANOVA really are concerned with the error that is calculated for your observed distribution. So the first one is independence. And here we want to look at, are all of these errors independent of each other? Are they independently distributed? Meaning that the error from one individual point or one group is not causing the error in another individual or another group. The second one is normality. And just like looking at normality of your continuous variables, we're doing the same here, but for the errors and the distribution of errors. So you want your normality to indicate that you have a normal curve of errors. And lastly, we have homogeneity of variance. And homogeneity of variance is really looking at the distribution of errors for each of the populations or each of the groups represented is the same, and that there's not a variation across the groups. So this way, when we look at is any particular treatment or whatever our outcome is and how that outcome is being impacted, how does that variance shift between the groups? Because that shifting of variance is what shifts the means to be able to compare those means and see if there's statistical differences. So it's important for the differences in the groups to not be from the violation of homogeneity of variance, but to actually be from a shift in the variance, thus a shift in the mean. So then for each one of these primary assumptions for ANOVA, they can be calculated in a number of different ways, but we'll give you just the primary ways of calculation. And so for independence, we tend to use the interclass correlation. And you can use this to really assess if you have independence of your errors within your ANOVA distribution. For normality, we usually check normality of the errors in a very similar way as you would check the normality of any of your continuous variables. So you can use the Explore feature, descriptive statistics, and really look at normality plots. You could also use skewness and kurtosis to be able to determine normality. And for homogeneity of variance, there's lots of different methods and different tests that you could use. The most commonly used is the Levene's test. And for the Levene's test, it tends to give you results with any program that you're using as part of your ANOVA output.